of rates of change is called derivative calculus. Or differential calculus, if you want to call it. Derivative calculus, I'll put in brackets. Differential calculus. When you go to university, once you take the first year of calculus, usually called calculus 1A and 1B, after that it gets split into, after like calculus 2, it goes into differential equations, it's going into integrate, it gets all crazy after that. So differential calculus is another word for it as well. So the process of taking the limits to find the slope of a line tangent to a point is called differentiation. Recall the definition of slope of a tangent line. We learned this in the last lesson. Is essentially y2 minus y1 over x2 minus x1. However, when it's a tangent line where we don't have two x's, it's so close together that this gap here is basically 0. So we'll go. I know a lot of people are confused by that, so I hope the visual of that video showed you where it's basically we're taking the secant line and getting that second point as close to that first point as possible. That's where we take the limits, right? Okay. So the derivative of a function, here is a definition. At any point is defined as f, this is a prime, not apostrophe, f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x, provided the limit exists. You will see many forms of this same, essentially, formula. They're all variables. It doesn't really matter which one you use as long as you understand how to use it, right? Okay, so the derivative is the same as slope. In this case, it's the slope at any point. We use the derivative formula to find the slope of a tangent to a curve at any point x. So we need to find the derivative. Now in the video it showed, because depending on where the point is, you see that the derivative would be very big here. Again, derivative is just slope. So do you understand, if my pencil is like right here, this is really big slope, and then the closer and closer I get, the slope changes, and then all of a sudden what happens when I'm at the vertex right here? It's a horizontal slope, and what do we know about horizontal slope? That's where the slope is 0. And then what happens on the left of the vertex? It's a negative slope, and then it gets steeper as higher up we get. So the whole point of this example right now is we're going to find the derivative at any point, not just at one specific point. So we're going to use this formula right here. So what do we have to know to use this formula? We have to know f of x, which is that, and we have to know f of x plus h. Okay, so we know f of x. Let's figure out what f of x plus h is. How do I figure that out? You plug it in. I'm changing the input from x to x plus h. So wherever you see an input, you're going to put an x plus h. So this becomes x plus h, the whole thing squared, plus 4 times x plus h. Is everybody good with what I did so far? Then we got to do what? Yeah, FOIL it out and simplify. So we get x squared. What do we get for the middle term? Plus 2xh. And the last term, h squared. Then I multiply this out. I get plus 4x plus 4h. Is there anything I actually can combine at this point? No. So now I'm going to plug it into the formula. So f prime of x, remember this f prime of x is the actual notation for derivative. I'm finding the derivative of f of x. Yep. The prime is just the notation for the first derivative. If I have a double prime, that means it's the second derivative. If I have a third little tick, That's the third derivative, et cetera, et cetera. At some point, they start using numbers instead of ticks because it's just too crazy. Yeah. So that's a great question. The one tick means it's the first derivative. If I put a second tick here, that's the second derivative. But we're not doing that yet. We got to find the first derivative first. So that is equal to the limit as h goes to 0 of f of x plus h. What I just figured out was x squared plus 2xh plus h squared plus 4x plus 4h. And then we have to subtract f of x. So I'm going to go subtract bracket. What is f of x? X squared plus 4x. All over h. I don't know whose bing that was. So again, this part right here is f of x plus h. And this part right here is f of x. Do you see? I'm just plugging it into the formula. Yes? We definitely can simplify this, right? Because otherwise, if I plug 0 in, I'm going to have it dividing by 0. The hopes is what? We're going to be able to factor out an h and cancel it, right? So let's go back to my... Okay. So equals the limit as h goes to 0 of x squared plus 2xh plus h squared plus 4x plus 4h. If you're really good at this, you probably would have done this already. Instead of subtract bracket, you actually just switch the sign. So minus 4x all over h. So what can we cancel here? We can cancel the x squared and we can cancel the 4x. Does everybody see that? So equals the limit as h goes to 0 of 2xh plus h squared plus 4h all over h. So if I plug it right in, I'll get 0 over 0, which means I need to factor. So don't drop the h goes to 0 yet because I haven't actually plugged in the h. So h bracket, I get 2x plus h plus 4, yes? All over h. Does everybody see the h's now cancel? Now I plug the h in, what do I get? You get 2x plus 4. What does that mean? The derivative of x squared plus 4 is x squared plus 4x is 2x plus 4, which means that if I know say for instance, if I want to find the derivative when x is 0, I plug 0 in for x and I know that the slope right there of the tangent line is 4. If I plug it in when x is say, I can't really read this right now, say -1, what's that slope? Plug it in, I get 2 as my slope. Do you see? That would be a slope of 2. Guess what happens when x value is -2? I get 0. I knew that was going to happen, right? Because I already said that the slope was 0 right there. Do you see how this equation is giving you all the slopes for any point on that parabola? Okay, is it starting to click a little there? All right. Oh, it says using the example, I probably did this already, didn't I? Using the example, the function in example 1, calculate the slope of the tangent line at x equals -5 and x equals 0. So I'll give you a second to do that. By the way, if f prime equals 2x plus 4, when I actually figure this out, it's not f prime anymore. It's actually m, because it's actually the slope. Once I plug it in, I'm actually getting the slope. So you can either do it as f prime of -5, like that. That would be a legit notation. So what do I get? -6. Or you can use slope, because that's what you're actually figuring out is the slope. Remember, we use m for slope. Either way, we're going to get the slope is -6. So what do we get for x equals 0? M equals 4. Some people get confused and they say m equals 2x plus 4, but that's not true because the slope varies depending on what the x is, so you can't say the slope is 2x plus 4. It's the derivative function is that. Okay, moving on. An alternate definition, and they actually use this definition on the AP exam quite a bit, is this alteration of it. F prime of a equals the limit as x goes to a of f of x minus f of a all over x minus a. So basically you're just doing the same thing except that you're using a's instead of h's, and you have x's involved this time as well. But you had x's last time, I guess. Anyways, so do you want to try this? Yeah? Okay. My advice if you're trying it, because there's two things. You already have f of x. You need to find what f of a is, right? So that's your first thing. Find what f of a is. This is going to be the epitome of factoring. Equals, does everybody got for f of a to be 2a minus a squared? Like that wasn't the hard part. Because I need to have f of a as part of my formula though. All I'm doing is replacing a with x, right? Yeah. Okay, so f prime of a is equal to the limit as x goes to a of f of x, which is 2x minus x squared, subtract bracket f of a, which is 2a minus a squared. Yes? Are we good so far? All over x minus a. A. Whoops. Okay, x minus a. Let's scroll her up. So, equals the limit as x goes to a of 2x minus x squared minus 2a plus a squared over x minus a. So here's the thing. If I plug in right now, does everybody understand? I know it looks goofy. It says x goes to a. Essentially, if that was x going to 2, you would be plugging 2 in, right? So if I plug a in right now, do you see I get 2a minus a squared minus 2a plus a squared, which gives me 0 on top. And then a minus a is 0 at the bottom. So that shows me I have 0 over 0, which means our strategy is factor. Now this is why I'm saying this is factoring at its finest. And you know the goal is I need to get an x minus a to cancel. Does everybody see that? So in order to get an x minus a, I might want to do this at a side at some point because this is just craziness here. 2x minus x squared minus 2a plus a squared. And your first thoughts might be, oh, I can factor out an x in the first two and an a in the second two. And is that x minus a? Well, perhaps. Let's try it. And again, part of the process in these questions is try, see if you get it. If you don't erase it. Try again. Then, if you don't get anywhere, you can see your process. If you get somewhere, then cross off where it did. Because on the AP exam, if you don't erase two processes, they mark both and divide it by 2. So if you get 0 on that and full marks on this, you get half of the value. So you have to cross off which one you intend them to mark. So anyways, so I saw some people doing this. They factored out an x and they got 2 minus x. And then they factored out an a. So I want an x minus a, so I'm going to factor out a minus a. And I'm left with 2 minus x. Oh, sorry, 2 minus a. Okay. And you might say,
You can root the x minus 2. Can you do that?
Well, I can do what I just did, but it's not getting me anywhere. I can see there's an x minus a that really wants to come out, but these don't match, so I can't actually factor that out. So I'm thinking my grouping isn't quite right. So I'm going to try this again. What do I want to group? Hey, The 2's together, yes. So maybe I want to group 2x minus 2a And then I want, I don't know, say minus x squared plus a squared together. And you might go, oh, that doesn't really look like you're getting very far. Remember, my whole purpose is to try to get an x minus a out of this, right? So if I factor out the 2, I get x minus a. Ooh, I'm getting somewhere. However, this causes some worry because I don't know what to factor this out. However, if I factor out a minus 1, I get x squared minus a squared. And you're thinking, oh, difference of squares, bonus. So I'm going to do this again. So 2x minus a minus 1. And then this is x minus a, x plus a. Yes? So, depending on when you or how you learned factoring in grade 10, there was what was called the decomp method. This is decomp at its finest, where you get this common term that now you're going to pull it out. So does everybody see at this point I'm going to pull this out and I get x minus a bracket. So if I take x minus a out of this term, what do I get? 2. Yay. If I take x minus a out of this second term, what am I left with? Minus 1 bracket x plus a. Huh? Well, it's kind of like I have to have that subtraction part of it, right? Because I have 2 terms. You see, I still have to have 2 terms when I factor it out. So I can't ignore that the minus 1 is not there. I don't know. I am taking a minus x minus a out of that. I'm taking this out and this out. This is coming out and this is coming out. And then I'm left with minus 1 times x plus a. Now I'm going to. I don't want to do too much at once. So I get x minus a, 2 minus x minus a. That doesn't really get me far. But I can go back up here and I get the limit as x goes to a of x minus a bracket 2 minus x minus a all over x minus a. And I can now cancel. So then I get, I'll write it one more time. Limit as x goes to a as 2 minus x minus a. Remember, we're replacing x's with a's. So does anybody know what I got? 2 minus a. So what do I get? 2 minus 2a. 2 minus 2a. That's the answer. Yes. The funny thing, we're going to be using the definition that has the f prime at a. Why do I know I want to use that? Because they're actually giving you an a this time. A equals 3. Does everybody see that? So we're going to be using f prime of a. I'm just going to rewrite this is, oh yeah, so the limit as x approaches a of f of x minus f of a all over x minus a. Okay, so what do we need to do to solve this question? We already have f of x. We do not have f of a. But in this case, I already told you a was 3. So that means I need to find f of 3. So what do I get? 3 squared plus 10 times 3. Yes? So 9 plus 30 equals 39. Everybody checking my work there? Oh yeah. Okay. So now let's go. F prime of 3 equals the limit as x goes to 3, because remember my a is 3, yes? F of x is x squared plus 10x. F of a is, so minus 39 over not x minus 3. Sorry, not x minus a, it's x minus 3. I plug her in. What do I get? 0 over 0. What's the strategy? We got to factor. So I'm thinking we need to factor x minus 3 out. You're pretty smart if that's the case, because our whole goal is to get this to cancel. So what does that have to be? Yes, it does. Does everybody see I'll get a 10x out of that? Do you see how you can save time factoring? It's not like you have to guess and check a million times. You know the goal is to cancel that x minus 3 out of there, right? So now you get the limit as x goes to 3 of x plus 13. So what do I get? 16. What does this represent? What does this represent? 16, the slope when x is 3.
Yes.
That's right. Yes. Because some people were asking some questions. Yes? Derivative notation. There's many ways to denote a derivative. Y equals f of x. We already learned that f prime of x is a derivative. So here is, like, if you have time, Google the controversy in calculus about who discovered calculus. Was it Newton or Leibniz? Leibniz? And there's a big controversy there. So anyways, you'll see basically different opinions on who did it first. Like, it's kind of like the chicken and the egg, who did it first, whatever, or whatever. You know what I'm saying? Yeah. Yeah. So anyways, Newton likes using y prime because a lot of his functions were always y equals blah, blah, blah. So he used y prime. Leibniz had the y, but he would have it as dy dx. Or if he used f of x, he'd use df dx. Or df of x dx. So you'll see this notation and this notation and this notation. So all of them mean derivatives. So you say this as dy dx. Sorry, maybe I should go back. Y prime, that is exactly how you say it, y prime. It's nice, brief, but it doesn't actually tell you what the independent variable is. Like, I have no idea if we're using an x, right? The next one says dy dx, derivative of y with respect to x. So it actually names the independent and the dependent variables, and it's using d for derivative. Okay? df dx, it's saying the derivative of the function with respect to x. Again, this notation versus this is just, it's emphasizing more the function's name. And d dx of f of x, f at x, or the derivative of f of x. Again, they all mean the same thing. Some people get all confused, like, I don't understand, like, what I'm asking. It's asking all the same thing. It's just a different notation, right? So it's kind of like when you first learned y, and then all of a sudden they threw in f of x. And people didn't know the difference between the two, but yet they were both the same, right? The only difference was f of x established that it was a function versus y could be any relation, right? So, but it both meant the output. Does everybody see that? Okay. So, we're going to find an equation of the tangent line to the parabola f of x equals x squared minus 5 at 2, negative 1. So, everything you've just learned in this lesson, can you actually answer this now? There's many ways that you can do this. There's a couple formulas to use. You got to just, and in a second, you choose one and do it. I'm going to do both in a second, so you decide. Which one am I going to do first? Which one do you want me to do first? First equation. So that is the limit as h goes to 0 of f of x plus h minus f of x all over h. Okay? I'm going to do this two ways, just so you know, okay? The first thing I need to know is f of x plus h, so I'm going to figure that out. that is going to be x plus h, the whole thing squared minus 5. So that's x squared plus 2xh plus h squared minus 5. You'll notice that this formula actually involves more work if you actually know the point. However, I'm going to show you the benefit of this form in a second. So the limit as h goes to 0 of x squared plus 2xh plus h squared minus 5, subtract this. So if I subtract this, I'm going to skip a step just for time, whatever. I'm going to subtract x squared, and now I'm going to subtract negative 5, so that's really plus 5 all over h. So do you see the x squares cancel and the 5's cancel? And I'm left with the limit as h goes to 0 of, I'm going to factor out what's remaining, an h out of this one, so I get a 2x, and an h out of this one plus h all over that. So then I get 2x. So this is the general formula for the derivative at any point. At any point. So if I want to know what the slope at point 2, negative 1, that is essentially f of f prime of 2, which is 2 times 2, which gives me 4. Guess I'm not done yet because I only know what the slope is at this point. So that's when I plug in. The point was 2, negative 1, and the slope is 4. Y plus 1 equals 4x minus 2. And the question is, can I leave it like that? You certainly can. However, the back of the book might have it simplified. So I know in grade 10 they made you actually multiply this out. So y plus 1 equals 4x minus 8. So y equals 4x minus 9 is the equation of the tangent line. Y equals mx plus b. However, at this point right here, you get full marks. If you make a mistake from this step to this step, you've lost marks. So you might want to stop there, right? Okay, I'm going to do the other one. That's f prime of a is equal to f of x, the limit as x goes to a of f of x minus f of a over x minus a. So does everybody some people didn't understand that the a was actually 2. So I'm at, yeah. So I get the limit as x goes to 2 of f of x, which is x squared minus 5, subtract, oh, I don't know what f of 2 is. Well, f of 2, plug it in, I get 2 squared minus 5, so that's negative 1. Yes? So that would be minus 1, so plus 1 over x minus 2. Yes? So I get the limit as x goes to 2 of x squared minus 4 over x minus 2. And if you were some people, you'd cancel, but that's not what you're supposed to do. What are you supposed to do? Factor it. If you plug it in right now, you get 0 over 0, right? This is a difference of 2 perfect squares. X minus 2, x plus 2 over x minus 2. Cancel. 2 goes in, I get 4. F prime of 2 is 4. That's the slope when x is 2. Then, once I get that, I plug it into there and I got the same answer. So what are the benefits of doing this formula? Because it looks like a lot more work.
It works for any point.
It works for any point. Does everybody understand this? When I find that the derivative is 2x, that works for any point. Doesn't matter when it's 2, because at no point did I actually say the x value was 2. It's not until here I plugged in the x value is 2. So if I wanted to know what the slope is at x is 3, this would work. What would I get for the slope? 6. If x was 10, it would be 20. Do you see that? Whereas here, once I'm done, all I know is the slope when x is 2 is 4. That's it. I can't figure out anything else. I'd have to do it again to get the slope at 10. So do you see the benefit over one over the other? So I guess what I'm saying is if you have a question where you're doing multiple derivatives of the same function, you would use this formula. If you're only doing it once at one value, this is faster. Do you see that? All right. Holy smokes.